So I suspect you'll find this last activity for Chapter 7 to be one of the easier ones. These are the last two patterns we're going to look at that are special for similar triangles. So in the previous activity, we looked at what's called the side splitter rule, and we had to look at three cases, one of which didn't work, and the other two cases will allow us to find a missing piece of the side if it's a proportion. In this activity, we're going to be looking at two special similar triangle patterns that involve angle. So in this first problem, consider that two objects are very close to each other, and the sun's hitting the top of those objects. They're very close to each other. The angle that the sun's creating with the ground will be the same for both objects. And if we assume that both objects are perpendicular to the ground, what we have here is a situation where two triangles are similar by angle. So again, that sun ray, again, we're talking about parallel, so that's why it's getting those corresponding angles again to be the same. So angle is the pattern that we're going to be looking at in this handout. So all you need to understand about this particular pattern is the triangles are similar. Actually, all the triangles are similar. We're looking at shadows to the object based on the angle being created, the ground being the same. So we're going to assume that the person or the objects are perpendicular to the ground, making those that angle case. So just like the previous problems, I suggest circling one of the triangles and using those as your bond numbers. 6 being a height, so I'll put an H here, and the 3 being shadow, I'll put an S here for shadows. And I'm going to set the ratios up so that I'm comparing the shadows and the heights, and the shadows and heights, those two scale factors should be the same number. So the shadow on the Statue of Liberty is 75. The height of the Statue of Liberty is unknown to us. This is the problem that we're actually solving here. So we're going to cross multiply. So we get 6 times 75, which is 450, equals 3x. And then we undo the multiplication problem with division. What we end up with is that Statue of Liberty is 150 feet tall. It's about 15 stories in terms of a building. So for the remaining problems, we're basically doing the same thing. We need to understand again the shadow height relationship that as long as two objects are close, we're going to be looking at an angle case. So if you see this special marking, whether that's a number, the problem's numbered, or the problem has a letter, those are problems you're going to be working on. So for this particular case, there's two more to look at. I marked out D and E. And then on this page here, I'm asking you to draw the pictures and then try to figure out the answer to each problem based on your drawings. The second case is where we actually use a mirror. And if I would stand on the ground with a mirror, or if I'm standing looking into a mirror that's on the ground, and if I move back and forth until I find the top of that object, what I've actually created again is another situation where we have an angle. The angle that's being created by the mirror is called the angle of inflection, and compared to the angle of reflection. Those two angles are going to be the same. And assuming that the object and the person are vertical to the ground, or perpendicular to the ground, that would create the second pair of congruent angles. So again, like the first example, this is another case of angle. So if you would take a moment and think about the four letters A, Y, B, and Z in your handout, and set up a proportion. There's actually more than one way of doing this. And set up the proportion and cross multiply. I'll talk about the two different cases, and then we'll move on to an example. All right, so I generally, again, am going to compare them up by shadow and height. So if I would choose the A and the Y being the shadow, A being the height, if I pair up Z and A, which are heights, the B and Y are the shadows, and if I cross multiply, I'll get B times A is equal to Y times Z. So if your proportion is set differently, as long as you have B times A equals Y times Z, your ratio will work. Another way of doing it that other students have done is they actually create a ratio of, let's say, height to shadow on both sides. So for the triangle on the left, the height is Z and the shadow is B. The triangle on the right, the height is A and the shadow is Y. So they need a ratio of the two objects, or two things that we're comparing. So if I cross multiply, I'll get Z times Y is equal to A times B. And if you look at the two sets of multiplication problems, you will see that they're actually the same. And this is what I mean, there's more than one way of setting these up. The key here is you should have A times B equals Y times C. A few problems for you to work on. We're going to take a look at the first one. So again, if I circle one of the triangles, it goes by bottom numbers. I'm going to let one of them be the mirror and the other one to be the height. So the 5 is the height, the 3 is the mirror distance. So the 3 and the 6 go together as both mirror distances. The 5 and the H go together as heights. By cross multiplying, 6 times 5 is equal to 3 times H. So 3H equals 30. If I divide both by 3, H is 10. So this height of this room is 10 feet. So this is where I want to stop on this handout. There are still 2 more problems on this handout to complete, plus the other ones I skipped. Your teacher has an answer key, so once you complete the activity, if you want to check the answers with your teacher, ask to see the answer key. And if you make any mistakes, go back and redo those problems. Otherwise, move on to the next activity.